Welcome back. So now that we have a bird pawn and it's actually flapping its wings, well, we now want to actually move the pawn, and that means we need to control the pawn. So let's discuss how that works in Unreal Engine. Now, in the engine, as soon as you start playing the game, a controller is spawned and assigned to you as a player. This controller is sort of your representation in the game. The game sees the controller and considers that to be you. Now, a controller allows us to select a pawn to possess. So we have a BP bird in the world, and this is a pawn. And if we'd like to control this bird, we need the controller that's assigned to us to possess the bird. Now, pawns have the capability of being possessed. Actors do not. So that's why we made our bird based on the pawn class. Now, as soon as we possess the bird, we can then control the bird and configure our project to be able to take input from the user whose controller is assigned to them. And with that input data, we can then manipulate the pawn. So as soon as we press play, we know that we have a controller. So how do we actually possess the bird? Well, all pawns have a variable called AutoPossessPlayer, and we can set its value. By default, it's unset, but if we set it to player 0 refers to the first controller in the world. Now, it's 0 because we start counting at 0. If there were more than one controller in the world, say in a multiplayer split-screen game, for example, then the first controller would be player 0 and the second would be player 1. But in our case, there's only one controller, and that's going to be player 0. So by setting our pawn's AutoPossessPlayer variable to player 0, this means that the first and only controller in our game will possess the bird by default, and then we can control the bird and make it fly. So let's see how this works in the engine. So here's our bird pawn, and by default, if we press play, we're not possessing the bird. In fact, we still have the default pawn, which has the capability of flying around like this, and we just see our bird flapping its wings right there. So we're not actually possessing the pawn. And again, that's because we need to set that AutoPossessPlayer variable on that pawn. And if we did that, then we would no longer spawn this default pawn. And by the way, we can see the default pawn by holding Shift F1 to get our mouse cursor and clicking this icon, which says detaches the player controller, allowing regular editor controls. So we know we have a player controller, and it's possessing this default pawn that can fly around. And if we click this icon, we suddenly can drag around in the world, and if we turn around, we'll see that default pawn. We can actually see a sphere, which is the default mesh assigned to that default pawn. Now, this doesn't exist in the world until we start playing the game, at which point it's spawned by default. And Unreal Engine does this because it doesn't see any other pawns that we've configured to be possessed. Now, we can change that by taking our bird pawn and setting AutoPossessPlayer. So with the bird pawn selected, we can search the details panel for AutoPossessPlayer, and here it is, and here's its value. Now, by default, it's set to disabled, but if we click the dropdown, we can assign it to player 0 through player 7. Now, when we talk about multiple controllers existing in a game, we're not talking about true multiplayer where two players are playing across a network. We're talking about however many controllers exist on our machine, and that's only going to be player 0 in our case. So if we select player 0, then as soon as we press play, then now we can't move around, and that's because we're now possessing our bird pawn. And if we hit Shift F1 and detach, then we can see our bird pawn, and we were attached to that bird pawn. So we don't see that gray sphere because we no longer spawn that default pawn as the engine understands that we're already possessing a pawn. Now we can click this controller icon that says attaches to the player controller, allowing normal gameplay controls. F8 is the shortcut for that. If we click that, we're now possessing the pawn again. And now we can't move around as we haven't configured any movement functionality for our pawn. So it's a little bit less exciting when we possess our pawn like this, but we're going to change that by configuring some inputs. Now, before we do that, I do want to show you that AutoPossessPlayer is a variable that we can set from C++ rather than doing it from blueprints like this. So let's hop back into Visual Studio, and here's our bird constructor. And if we want to set AutoPossessPlayer here, we can do that. So let's go ahead and type AutoPossessPlayer, and if we hover over it, we see its type. Now, it's an enum of type eAutoReceiveInput, and the type might look a little confusing because it's wrapped in a TEnumAsByte wrapper. We call these wrappers, and you can see that it has those angle brackets indicating templates. So this wrapper stores an eAutoReceiveInput type, and we can set this. So if we set it, we can choose an eAutoReceiveInput enum constant value. So if we type eAutoReceiveInput and hit the double colons there, we see all the possible enum constant values that this enum has, and we can select player 0. So that's the type of AutoPossessPlayer. It holds an enum of this eAutoReceiveInput type. And if we right-click, we can peek the definition of that to see that it's defined here in engine types. And it's in a namespace eAutoReceiveInput. That's why we needed to use the scope resolution operator. You might recall back to regular C++ when first learning and you use cout, and you might have put std : cout because cout was in the standard namespace. Well, this is the same thing here. We have the eAutoReceiveInput namespace, and here's that internal enum contained within it that has these different enum constants, including player 0. So this is how we set AutoPossessPlayer from C++. Okay, so now that we understand that, let's talk about how we can configure input for our project and use that input to actually move our bird. So let's hop back into the editor here. And here in the editor, in order to configure inputs, we have to go up to Edit and select Project Settings. And here in Project Settings, we can scroll down, and in the Engine section, we have Input. So go ahead and click on that. And under Bindings, we have Mappings. We have Action Mappings and we have Axis Mappings. Now, these two are similar, but their functionality is slightly different. We'll talk about Axis Mappings in this video, and we'll get to Action Mappings in the future. So we have Axis Mappings. And if we click the plus icon, we suddenly have a drop-down next to Axis Mappings that we can expand. And we see an item here called New Axis Mapping _0, and we can rename this. I'm going to go ahead and name this to Move Forward. And now we've created an axis mapping. Now notice that it has a drop-down, it has a scale, we'll talk about that very soon, and the drop-down allows us to choose what type of input we want to assign to the Move Forward axis mapping. And we have different types. If we expand keyboard, we have all of these keyboard keys. So if we wanted to use the W key for this axis mapping, we could. And this icon here, if we click on that, well, then we can hit a key on the keyboard and it would change this to that key. So I can click that and select W. So what exactly is this axis mapping and how does it work? Well, let's talk about it. Unreal Engine has the concept of axis mappings, and we can create axis mappings, such as the one we just created called Move Forward. Now, an axis mapping has one or more keys assigned to it. We assigned the W key to move forward. So here's how it works. We're going to create a function on our pawn, specifically on our bird class. Now, we can call this Move Forward or really any name we want, but it has to have a float input parameter type. We usually call this value. Now, the reason it has to have a float input parameter type is because that's the type of function that can be bound to move forward. So we perform the action of binding the function to the axis mapping. And once that's been done, we suddenly have this connection between the move forward axis mapping and our newly created function called move forward. Now, once this relationship is established, then our move forward function is going to start being called every single frame of the game. And inside the body of this move forward function, we can access that input parameter value, and its value is going to be different depending on whether or not we're pressing the W key. Now, if we're pressing the W key, then every single frame move forward is going to receive a value through its value input. And that value is going to have a particular numerical value. And by default, that value is going to be 1 when the W key is pressed. Now, if we're not pressing the W key, then the numerical value of our input parameter is going to be 0. And we can use this information to do something with that value in the move forward function. So we can check to see if it's 0, and if it is, we can do nothing, and if it's not 0, then we can move the bird forward. Now we saw that there was a scale assigned to move forward, and its value was 1, but if we change that value, then our input parameter, called value in move forward, will be scaled by that scale value. So if we change scale to 2, for example, then every single frame, if we're pressing the W key, then the input parameter's value will be 2 instead of 1. So this allows us to customize the input. Now, if you're not pressing the W key, it's still going to just be 0. So we can still use that information. But this is useful because we may wish to assign scale a value of -1, in which case we could use that value, and when our key is pressed, then because we'll have -1, we could use that to, say, move the bird backwards. And of course, we would still get a 0 if the W key is not pressed. So that's how we use this type of information in that move forward function. Now, the function that we use to bind to our axis mapping is typically known as a callback function. So we call move forward our axis mapping's callback. So where do we do all this binding? Well, we noticed when we created our first pawn class that it had this function, setUpPlayerInput component. This is where we do all of our axis mapping bindings by assigning a callback function to a given axis mapping that we've created in our project settings. So let's do this for our move forward axis mapping. So before we hop back into Visual Studio, we're just going to look right here at our axis mappings and remind ourselves that this is the name of our axis mapping. It's called move forward. We have the W key assigned to it, and its scale has a value of 1. So back here in bird.cpp, we can scroll down to setUpPlayerInput component, and here is where we're going to do our binding. But we can't do any binding unless we have a callback function. So let's make one, and we're going to declare that here in bird.h. Now, I typically make these protected, but you could easily make them private. You could even make it public, but we don't plan on calling this outside the class. So we're going to make this a protected function, and that way if we ever need to call it in a child class, we can. So let's make this function. Now, it has to be a void function, and we're going to call it move forward to match our axis mapping name. And it has to take a float, and we usually call this value, but you could name that input parameter anything. Now, I'm going to define this function. So I'm going to hover over, click the drop down, and select Create Definition of Move Forward. And now I'll get it here in bird.cpp. So this is going to be my callback function. So I need to bind this to the move forward axis mapping. So let's do that. So down here in setUpPlayerInput component, we're going to bind our callback to the axis mapping. And we do this using this player input component. So setUpPlayerInput component will be called very early in the game, and it takes an input of type uInput component called player input component. Now we can access this pointer and call functions on it. And the uInput component class has functions for binding callbacks to axis mappings. So let's access player input component, and we'll use the arrow operator to call the function bind axis. Now, bind axis requires the name of the axis mapping, and this is an fname. Now, an fname input parameter can take a string literal. So if we wanted, we can just pass in the string move forward. Now, we could also wrap this in a text macro if we want to follow good practices and wrap it in text like we should. And alternatively, another option is to simply pass in an fname and use the fname constructor, initializing it with move forward. So these are all ways that will work with bind axis. Now, if we hit the comma, we'll see that there are multiple overloads of bind axis. And the one we see here, 2 of 2, requires 2 more input parameters. One of them is a user class pointer. Now, user class exists high up in the hierarchy, and our bird pawn is a distant descendant of that class, which means we can pass in our bird pawn. So if we use the this pointer, this is a pointer to the object of the class that we're in. So if an object of the bird class exists in the world, when setupPlayerInputComponent gets called, by passing this into the function, we're essentially passing in a pointer to this bird object. Now, the user object is the object who has the function that we're going to bind to the move forward axis mapping. That's going to be our bird's move forward function, which we have right here. Now, that's going to be the third input parameter. We have to specify the function. So we need to pass that function in as an input. Now, how do we pass a function into another function? Well, here's how. We're used to pointers being variables that store addresses, right? And typically they store addresses of some object that exists in memory. Well, functions themselves have addresses as well. So we could have addresses of functions. Now, in C++, if you recall, this symbol, the ampersand, is the address of operator. So if we use this, then whatever comes after that, we're going to get its address. And we want the address of our callback function, move forward. So to pass the address of move forward into this function, we use the address of operator followed by the name of the function. But the name of the function has to be fully qualified with the class name. So we can't just pass in the address of move forward. We have to pass in the address of this whole thing here, a bird, : move forward. So I'm going to copy that. And down here in bind axis, I'm going to pass in a bird move forward. So this is how we can pass the address of a function in as an input parameter to another function. So this line here is how we bind our move forward function to the move forward axis mapping. Now, as soon as we do this, that means that when the game is playing, then our move forward function will now be executed every single frame. It's kind of like the tick function, only instead of delta time, we get value. And value depends on whether or not we're pressing the button or key that's assigned to this axis mapping. And remember, we assign the key W. So we can test this out by printing an on-screen debug message or a UE log. So I'd like to use a UE log. So we're going to type UE log, and we're going to make this a log temp with warning as the verbosity, and we'll use the text macro, and we'll say value, and I'm going to use the format specifier %f, and if I do have %f here, I need to provide a float value. We're going to use our input parameter value. So now we should see a message printed to the UE log every single frame, showing us what this value is. So let's hit Save All, And back in the editor, we're going to hot reload. So let's go ahead and do that. And after live coding, let's go ahead and open up our output log. And I'm going to click Dock in Layout so we can see it and keep it open here. Now with our output log open, we're going to click play. And right away, we see this log message spamming the output log. Now we can click in the viewport to gain control of our pawn. And if we press the W key, check this out. We see the value 1. So this is actually showing us that our axis mapping is working and our move forward function has successfully been bound to it. So this is great. Now we can use that function to move our bird. And we'll do that in the next video. I'll see you soon.